Hi everyone, I'm super excited to host Mohamed Adil, founder of Awatif. Thanks a lot for being on my show.
Thank you for inviting me. I'm really also excited to join this discussion.
Take us back to your college days and from there to till this date. What were some career highlights?
Career highlight. Actually, this project I'm still working on, it started during my master thesis. Probably a lot of people use Grasshopper, and there is a physics engine called Kangaroo, developed by Daniel Picker. It was very fascinating. You can do like real-time FEM analysis and you move the structure with the mouse. I was really fascinated about it. So I decided to do my thesis on that. So that was the topic actually for me. Let's see what is behind this physics engine. And I ended up starting this project, doing my thesis, and actually find the topic of my dreams. So it was, I wouldn't say I changed a lot in terms of passion or career wise. And I was always committed to this idea. I think I'm kind of lucky to find something that keep me motivated and doing it for the long term. And now it's almost 6-7 years since I have been graduated, so it's a long time ago.
I see. So after graduation, like from the work experience, how did you develop all the skills? Who were your mentors?
My thesis mentor helped me a lot because he was quite knowledgeable about the topics. I did it in the Netherlands, both in Eindhoven University and TU Delft, which are one of the best university in the Netherlands. So they teach me a lot about the fundamental behind the math and how to, discretize, how to, use the real math. Because before doing my master thesis, I was just using the software without really knowing how this software works, like the FEM simulation, the structure analysis. But when I did my thesis and really getting behind the fundamental behind it, I learned a lot, and that really helped me think in a clear way how we solve the problem, how we can replicate this kind of software. The famous one are ETAB, Dulupo, and try to make it better, because I think they haven't been changed since a long time. So that's one of the aim of what we're trying to do with Awatif as well.
Yeah. And like
And in
that's
terms of careers, I was also working alongside this project. I worked in a design company who were assessing the earthquake damage in the Netherlands. So that teach me a lot about dynamic simulation. And I also shifted completely from structural engineering to software development in order to really understand how to develop a proper software. It's always a difference between like you doing a script in Python or Grasshopper, or you build an actual software for a company that make revenue from the software. So I learned a lot, and I really recommend people to go through this path. So working with other teams, see how the progress work, how you collaborate, like a team of maybe 80 people working on one code base. That's a huge task. And this has also shaped a lot my skills in terms of software development, architecturing, alongside with the structural engineering skills, which was I also did before my master for almost 5 years. So these kind of two industry, they kind of shape who I am now.
this is so like very unique path because we see very few people taking the leap from like low code automations or coding in structural engineers to like full time. Can you share what are various like things you had to learn in terms of algorithm, language? How can one, like if you were to write a course on becoming a software developer for structural engineering, what are the things one should learn?
I think the best thing you should keep in mind is always to ask the question why. Don't take your learning for granted. This is something I think we used to do with the way we teach in school. They usually just this is the equation, we solve it this way, but the why is always not there. And if you have this mentality, always ask why we do this and why, then you always try to find like the principle behind how this knowledge or fact has been driven. There is always like accumulation of knowledge that at the end came to this fact. But if you know how things develop, that will help you understand way much than just try to understand how things works. To give more concrete example, like Programming in Grasshopper, this is a very high level. If you go a bit low level in Python, still considered high level because you don't know like how memory is managed. Then if you go to C++, you will understand more like why Python is being developed this way and why it's slow. What is the
Mhm.
limitation? Even though it can be considered high level to assembly. And, we can go more down to the why, even to
Mhm.
reach the level of logics. But this is not the point, but try to reach as deep as you can with any kind of knowledge. That will help you to understand the big picture. And I think this is like a generic advice. And this
Yeah.
is what I did. I always try to ask why. I didn't do the assembly part, but I think I learned a little bit of C++ memory management, and that helped me a lot with understanding even like Grasshopper or Excel. So it's all related.
Yes. Like during my computational design days, I was playing with Kangaroo and doing like structural analysis, and I was like so amazed by the accessibility it enabled for like parametric way of doing analysis, as how good a physics engine it is which they have developed. So what was your like curiosity? You mentioned about okay, ETABS and other software haven't been adapted since a long time. I'm guessing part of it is like for someone to build it from scratch is so many components in terms of engine functionality one has to develop, and it's a very long project. It's not a hackathon or short term. So can you break us down the complexity of the problem you're solving?
Yes, it's like a funny coincidence. Like the math behind it is actually one equation, which three letters is F equal
Equal to
ma, and but this like second order differential equation, it's really hard to solve, and
mm,
this make the complexity of let's use finite element. And even like if you want to design a building, there is many edge cases. You have earthquake, you have like different materials. So it starts simple but growing complexity very very fast. And what like you saying is not like a hackathon, but if you start simple, you just realize this is my realization as well, how simple it is if you have the correct guidance. So I dedicated my thesis to just understand how nonlinear FEM do. So it was 8 months, and I realized in the first month I wrote the code, which was 50 line of code in Python, and it's done.
mm.
And I was like, okay, maybe it's not as complicated as people think. The complicated part is maybe you need to have the correct foundation. This is what usually people what missing, like correct foundation in terms of how you program, how good are you in linear algebra. So it took me a lot of time to get these fundamentals first. Like it really took what I learned in school, like linear algebra, those calculus, and also programming, like what is algorithm data structure. Then if you have the good basics, it's become like very trivial to do like an FEM simulation similar to ETAB. I'm not down how you call underestimating the capabilities of these applications. There is a huge work, but they were more specific. They were more focused on specific problem. But like a generic FEM solver, that's something you can do in a weekend.
So like why don't we see more of such solutions if the core engine is not of a challenge? Like, what was the bottleneck? We don't see a lot of new ETABS competitor.
That's a good question. That was also my concern. Well, if you look online, there is a lot of alternative, open source alternative, like in Python, in JavaScript. But I think the main problem is like the black box syndrome, and it's hard to trust an application, especially if you're designing a very sensitive structure like structural engineering. Like the error could mean a disaster. So because of this trust thing, certain apps made it to the top because of just trust. People love it. They know it works as they expected. They did their own validation before, and that's the main reason why it's hard for newcomer to compete, or there is other existing. I'm pretty sure there is a lot of in-house tools usually used where they also build their own FEM. But to reach to the level of those bigger application, it takes a lot of effort. Because as I told, they are more focused on solving a specific problem, and to get this specificity take a lot of time.
I see. I'm just sharing my screen about to show the website of Awatif. Uh, we'd love to know, like, from the initial days to this version, what were your intimate milestones and how did you like build the app?
It actually, I pivoted twice. Let me remember what was. So the first idea, if you go to the blog, maybe I can show some animation. Go to the first post. I think it was go down 2000. The first step toward interactive simulation. The second thing, yes. So this is how the idea started. If you play the video, so this is like a simple 50 line of code of Python where I run dynamic simulation, and I like the idea of interactive simulation. Like imagine this kind of cube or rectangular shape. It's like you're building or a truss, and you interact with it with the mouse, and you can see the stresses, the displacement in real time. So I really like this idea. It kind of went viral, as you can see.
Yeah.
And but when I try to work on it more, I realized there are more low level, like fundamental problem. It's like a nice thing to have, but parametric modeling, like how you model the structure in an efficient way, that was more valuable than having interactive simulation. At some point, I will get back to this nice simulation. I think it's very valuable. It gives you a lot of insight how your structure work. But now we're focusing on other fundamental problem, which parametric modeling, and this is the platform is about. It's just a parametric platform that is different from Python or Grasshopper because it's web based. So if you go to the examples, it's just a matter of at the right side. Maybe you can open the one on the top right.
This one, 3D?
One on the 3D structure. So this is how we imagine like an FEM solver running it. Are you with me?
Yes, yes. I think maybe.
The network. So if you change the parameters here, then the analysis is also running in real time. So this is what we're trying to do, like build your structure in a parametric way, in the same time attach it to a finite element. So if you change the load to just prove it is a real-time analysis, this is the load at the top. As soon as you increase, the deformation increases. And if you want to read like the internal forces, you can go to the settings at the top left, the frame result at the bottom.
Yeah.
Yes, click on it and choose normal forces. And maybe decrease the display scale at the top so it can be more visual. So this is the internal forces. The actual one, like 10, I see 18 kilonewton tension and compression in both sides. So this is in a nutshell what we're trying to do, but now we focus on a building instead of truss. If you change the column location, you know, the displacement, and you can have like instant decision with the architect about how your structure is behaving.
So how do you imagine the workflow? Is it quick interactive analysis, so making analysis accessible to architects, or for structural engineer for in the conceptual or as schematic stage, quickly do analysis and make decisions?
Now we focus on the schematic stage because it's simpler to tackle. But if you want to tackle a problem like details stage, this is because of, I think, because of the name details mean it's heavily detailed and it takes a lot of effort. But the real roadmap is to reach to the level of like you can produce drawings, can produce structural engineering report from this parametric script. So if you want to see an example, like if you want to see the report here, press on the report button at the top left, top right.
Oh yeah, okay.
So this is like a sampled report from this parametric modeling with the reaction, with the support. And if you change the parameters, the report will instantly update as well.
Okay, okay. I see.
Yeah. So we aiming to have like this one unified platform where you can do the whole process from the geometry until the reports and the drawings.
It's very exciting. So there's one major component of analysis, report, Excel export. Do you also envision modeling capabilities more added, or one should model it in Grasshopper or like Rhino and then, or maybe Revit and import it here?
This is actually a work in progress. I can show you something that is not finalized, but if you go to this link, or if you can go to the like example, the name called Slab Designer after the examples at the in the URL. If you can see on,
Okay, I see.
just type slab dash
Okay.
designer. Yes, this
Mm.
example. So we're trying also to incorporate the modeling. So these red dots, these are the column. Try to change the column location. And what is more interesting, like if you visualize, let's say the displacement, go to the settings, shell result, then visualize this and remove the solid so we can see the displacement, the last one. Yes. Try to change the columns, location, put them inside the building, for example.
Oh yeah.
So this is like a real-time simulation that show you the effect of the column that you just added.
This is
And you can
so good.
yeah.
Nice.
So we're also incorporating modeling. So what we envision, like if you have an architecture plan, you import it to this app, you draw the outline of the plan, you draw the column location, and that's it. This is your input. Then you can do FEM analysis, you can do lateral system. Like we do it in a parametric way. Like you choose the lateral system you want. Is it X bracing? Is it shear walls? Is it moment? And you select the parameters. Then the modeling will happen in a parametric way. So we call this like a hybrid approach. You manually draw the column location, but the system is generated automatically or parametrically. So with the manual drawing, you have the flexibility to draw whatever you want. With the automated lateral system or gravity system, you save a lot of time of generating this system instead of drawing them, expressing one by one. That takes a lot of do this for weeks, but now it's way much straightforward.
And it's how do you envision the future roadmap? Can people contribute to this? Like
Yeah,
it's open source.
if you go to the at the bottom of this page, there is the repository. It's a very active repository, and we're working on it. Like now we have a contributor of five
Mm.
who are committed, but there are some also people who just find a bug and they are interested on working on a specific feature. So this is like all community driven. Everything I showed is open source. Like the FEM Solver, we written it in two language, JavaScript. Then we run it in C++ because it's faster. This is why you can see like it was very fast. So it's all open source under MIT license. We are not doing this to make like a VC funded company. We're doing this because we just like what we're doing and we have this common vision. We need to improve how we design structure.
This is amazing, man. It has been a while we have seen like such a big initiative and open source for structural analysis.
And we are quite open. Like even the monthly meeting where we just showed, these are also open. Anyone can see them. See how we come up with these ideas and why we come to these discussions. And if you look at the issues, how we work, we don't have anything to hide. So it's really open.
And is it like because C like is more performant, like using WASM you convert that simulation?
Exactly.
Okay.
There is a funny story behind this. Like I knew from the beginning if I'm gonna write the solver in JavaScript, it's not gonna be as fast as C++. So I started with C++, and I realized the development is very slow. And then I shifted back to, after 6 months actually, I shifted back to JavaScript. But what's funny, like that was 4 years ago. Now the agentic AI came and I converted my JavaScript to C++ in one day. and it works
Whoa.
as I was intended to do. So it's really worked well for us, and I think the decision I made at the beginning was luckily working fine.
It's interesting you shared, because when you were initially talking about it and you were thinking components, and right now I'm experimenting a bit with MCP server, agentic tool calling,
Yeah.
and it gave me an idea. It might be cool where I can say add a bar at this position, add a column, make a slab, X braces, and then agentic can infer the instruction. And
Yeah, at the beginning, like I was a bit hesitant about AI, especially with FEM. I still, because we cannot accept like 10%, error. But for the modeling, for all the remaining tasks, I think it has great potential. But for FEM, I think we still really value like 100% accuracy. So this is why we didn't invest a lot of training. And we can train FEM solver, but I don't think the black box problem I was talking about. This is not gonna help at all.
I see. What
Yeah.
are like some other open source projects in structural engineering or construction you find useful?
3GS. This is the viewer we are using, the 3D engine. I mean, it's helped us like in all aspects. Because at the beginning I tried with WebGL and I realized it's a lot of work. Then I used 3GS and I was just happy this kind of library exists. And it was also open source. It's well tested. And for the FEM, there is OpenSeas. We use it sometime to validate for FEM, and there is Calculatus. We actually use it to develop our shell element because it was a bit complicated to get it from the paper directly. So there is a lot of benefits from open source community, and because we are taking from them, we want to give back. So I think it's just a fair share of knowledge.
Nice. Okay, I want to move to a section about, in terms of, apart from, let's say you had to learn the simulation as well as JavaScript for UI and so many things you have to figure out. So looking back, is there anything you wish you would have faster or sooner that would have accelerated your learning journey?
Yes, definitely. And that's actually the main reason also why it's open source. It's like the other people knowledge. Like I don't need to be good as UI. I'm still not good. Like for 3GS, we have a person who is really good at 3GS and we always delegate the task for him. He's Abdurrahman Mizri, just to mention. I'm more focusing on the solver because this is what I like. This is the passion. And we have people who like to do in the calculation. Cal Menton, he do the report, the calculation, because he's a structural engineer. He's still working on it. And we have a PhD student who is doing his research actually in how to improve structural design using AI technologies. And he is the AI guy. This is Mus'ab Mahjoub. And just to mention the last one, because we are five, Kaisen, he's the joker because wherever we need a thing, he always help and he can solve the problem. So this is
Nice.
this is what I think. If I start doing this from the beginning, like open source, because I worked solo for 3 years, I would done or achieve way much more because the
Mm.
last years as a group we achieved like 5 times what I achieved when I was solo in 1 year. Try to
Another big
delegate.
reason for open.
Yes.
Amazing. I have a final section which is rapid fire. You'll have 5 to 10 seconds to answer it, and you have to keep it super brief. Okay. Who is your structural engineering role model?
I forgot the name to be honest. From Arab, Tristan.
Okay.
Tristan. I forgot the last name.
Yeah. Any book which made a big impact in your life?
No, I read summaries of books, so I don't really read books. So there's no particular thing, but self-help or how you call it, self-improvement books. Although some
Mm.
people find it cliche, they are very valuable if you need, especially how to deal with people or how to build network. I remember I read many book like the classical one, Seven Habit of Highly Effective
Mm.
People.
What's your favorite building?
Favorite building, the Olympic Stadium in München. designed by Frey Otto.
Nice. 3 words your friend would describe you as.
Outside of the box thinker and long-term visionary and funny.
Your favorite restaurant?
Favorite restaurant? I'm bad with names, very bad with names. But when I visited Musab in Barcelona, he invited me to a restaurant, but I really forgot the name. But maybe I will slack it to you or send it.
Which city or adventure is in your travel bucket list?
Budapest.
For people interested in contributing for this project or reaching out to collaborate with you, what's the best way?
My LinkedIn profile. So it's Madil, then number 4.
I had a great time interviewing you. The project you're building and the whole team and the collective for this is incredible. I wish you good luck in the next stages of building Awatif.
Yeah, thanks. I really enjoyed talking to you, and thanks again for the initiative. We need this kind of collaborative discussion where we can move forward together rather than every company working in their own things.